We assigned just 7 questions for homework last night because we felt like you guys were doing a good job on this. But there are 3 of those questions that you guys have asked us to go over here today, 4, 5, and 7. So let's take a look at number 4 here first. It says, determine the acceleration of a bullet starting from rest and leaving the muzzle of a gun 2.75 times 10 to the negative 3 seconds later with a velocity of 460 meters per second. Remember somebody yesterday in the second class, grade 2 class, asking me about this question. And we ended up getting a really, really high value of acceleration. And they were questioning that because it was so high. We should predict a really high value of the acceleration, right? You're going from 0 to about Mach 1.5, about 1.5 times the speed of sound, in a time of 2/1000ths of a second. So basically, in 1/500th of a second, you're going from 0 to Mach 1.5. That's got to be a big acceleration, right? It's a big change in velocity, but it's not because it's such a big change in velocity that it's such a high acceleration. It's because that change in velocity happens so quickly over a time of 1/500th roughly of a second. It is an acceleration problem. It is a group B problem. What do we got here? A time interval of 2.75 times 10 to the negative 3 seconds. Something is 460 meters per second. That's a velocity, right? But is that VI? Is that VF? Is that just V? It's VF, like the final velocity. Is there anything else that we have if we read between the lines here? Good. What's the initial velocity? Good. Now, in the case like this, it does say it starts at rest. Sometimes we say, like, you can't just assume it starts at rest if it doesn't say so. In a case like this, you probably could assume that it starts at rest, even if it doesn't say. And why? Because we're talking about a gun, right? If the gun is accelerating, or if the bullet is accelerating after it's fired, well, then it's starting at rest, whether it says that or not. We're looking for the acceleration here. We're just going to go back to that basic acceleration equation, I think, and say A is equal to delta V over delta T. Delta V is VF minus VI, 460 minus 0 over delta T of 2.75 times 10 to the negative 3. And what do we end up getting for that value? Who's got that? Yeah. 272 meters per second squared, which we should round to how many digits? How many? 3 digits, yeah. So we're going to say 1.67 times 10 to the 5 meters per second squared. Again, I've said this many times, we'll say it many times again. In this unit, we're not going to zing you marks on a quiz or a test because you put this answer. Okay? Starting next unit, we will zing you marks if you don't put in the right number of sig figs. So if you're ever not sure, when we say it's 3 sig figs, if you're ever not sure why it's 3 significant figures, ask me. Ask me when it doesn't count, as opposed to waiting for when it does count. All right, the next one we need to go over is question number 5. This is just some aircraft are capable of an acceleration of 42.5 meters per second squared. Remember yesterday we talked about, I think it was yesterday, we talked a little bit about G-force. You guys remember what 1G was? Basically, you feel as heavy as you really are. 2Gs is you feel twice as heavy as you really are. If you were experiencing an acceleration of 42.5 meters per second squared, roughly how many Gs would that be? How many times heavier would you feel than you really are? Not 42. About 4.2-ish, 4.3. Because 1G is 9.81, right, or 10. So 4 Gs would be about 40 meters per second squared. The aircraft starts from rest. How long will it take the aircraft to travel down the 2.6 kilometer runway? This is an acceleration problem, group B. 42.5 meters per second squared is the acceleration. VI is 0 because it says it starts from rest. We've got a displacement here of 2,600 meters, 2.6 times 10 to the 3 or 2,600 meters. And we're looking for delta T here. What do you want to do for this one? This one's a bit tougher. especially once you get trying to rearrange it. Yep. Okay, that's the one that I would use as well. The trick here is that we're looking for t and it appears in two places. The good news is VI is 0, so 0 times t, whatever t is, ends up disappearing, right? 0 times t is 0. So now we've got d is equal to 1/2 a t squared, which makes it quite a bit easier to rearrange. Get rid of what's not attached first. Well, there's nothing that's not attached. Get rid of what is attached next. So how do we get rid of what is attached? Well, 1/2 a is multiplied by t squared, so I'm going to say d divided by 1/2 a. Is t squared. Really what I've done there is divided both sides by 1/2 a, right? But I just kind of skipped the step of showing it on the right-hand side. Then what do I got to do? Square root it, right? So we're going to square root both sides, and we end up getting t is equal to the square root of delta d over 1/2 times the acceleration. So we're going to say it's the square root of 2,600 meters divided by 1/2 of the acceleration of 42.5. What are you going to get for that? 11 seconds. Should be 2 digits, right? 2 digits. This is 3. This is 2. Should be 2 digits, right? And finally, question number 7 says, approaching a flashing pedestrian activated traffic light, a driver must slow down to a speed of 30 kilometers per hour. Crosswalk is 150 meters away and the vehicle's initial speed is 50. What's the acceleration that's required to reach this speed limit? I'm going to say that VF is 30 and VI is 50. My displacement is 150 meters. And we want to find acceleration. Is that all I have? Let's do the conversions here. 50 kilometers per hour was, I think it was, I don't remember, 13.88. And 30 kilometers per hour was 8.33. VI, VF, A, and D. What do you want to do here? Remember, it's group B. So you got to pick from one of those 5 equations. If you're not sure which one to pick from, what should you do? Just pick one. Go with it. If it doesn't work out for you, pick another one. And so on and so on and so on. Yeah. Yeah, that's what I would do as well. We're rearranging to solve for A this time. Okay, this is one of the harder ones to rearrange for. What do you got to get rid of first? What's not attached? What's not attached here? VI squared. How do you get rid of it? Subtract it. So really what you're doing is subtracting both VI squared from both sides. We're just not going to show it on the right-hand side, just to save a little bit of space and time. Then you got to get rid of what is attached. What is attached to the A? 2 and the D. Now you can get rid of both of those together if you want. They're both multiplied by A, so how do you get rid of them? Divide. So we're going to say VF squared minus VI squared over 2 times D equals A. Does that make sense? If you're having any trouble with that algebra, with that rearranging, we're going to have that little session at Scheduled Help today to help you out with that, all right? So it's not mandatory. You don't have to be here for that. But if you're having any trouble with algebra whatsoever, please stick around for Scheduled Help there, okay? VF, 8.33 squared minus VI, 13.889 squared divided by 2 times 150. Let's do this on the calculator here. Let's say 8.333 squared minus 13.8889. Not that. Let's put the equals, and then let's divide that by, use some brackets here, 2 times 150. Yeah. Oh, let's start again. 8.3333 squared minus 13.8889 squared. Now let's divide that by brackets 2 times 150. We get negative 0.41. Is that right? Should be 2 digits. What does the negative mean here? Yeah, you can think of it in 2 ways, actually. You can think of it as a negative acceleration. So if you're moving to the right, it's an acceleration to the left. Or you can think of it as a deceleration. It's the same thing. If I'm moving to the right and I'm slowing down, then that's an acceleration to the left, a negative acceleration to the left. Yep. No, that's a good question, though. The question was, if it's 2 digits, shouldn't it be just 0.4? The rule for significant figures is that leading zeros don't count, trailing zeros do. So if you've got a number like 0.41, that's 2 digits. If you've got a number like, okay, so that one doesn't count, that one does, that one does. If you've got 403, 0 counts because it's in between. If you've got 430, the 0 counts because it's trailing. So any number, any 0 that's leading doesn't count as a significant figure. It's basically a placeholder. Any number, any 0 that's in between other digits or after other digits is going to count. Does that make sense? Even on a quiz or a test, guys, hey, especially over the next couple of weeks before we do our unit tests, ask me. Be conscious of significant figures, but if you're not sure, just ask me, because I'll help you, right? On a quiz or a test right now, I'll help you with it, because it doesn't count. Yeah. How would I express time in significant figures? Like if you have 12 seconds, but it should be rounded to 1 significant figure, you do it the same way as you would anything else, right? You'd have to put that in scientific notation. It would be 1 times 10 to the 1 seconds. Okay? Most times you're not dealing with 1 significant figure. Certainly when you're looking at that, it's like, wait, like we're rounding 12 seconds to basically 10 seconds. But yeah, if our least precise piece of data is only 1 digit, like as much as you say, like, that doesn't seem to make sense, it does. And if our least precise piece of data is only 1 digit, then our final answer, even if it's time, can only be 1 digit. The chain can only be as strong as its weakest link, right? You guys feel good? Okay, let me put up a quick question up on the board here now, and then we'll move on. All right? Let's say that a car begins at rest. It's okay. You don't, if you want to, you can. If you don't want to, that's okay too. Now, this is just a practice question in preparation for your quiz tomorrow. Okay. So car begins at rest, accelerates at 2.0 meters per second squared for 7.0 seconds. Then travels at a constant velocity. For 15 seconds. Then slows down to a stop in 8 seconds. The question is, what's the total displacement? What's the total displacement? Yes, that acceleration should be 2.0 meters per second squared, not 2.0 meters per second. All right, so this is one of those questions like we did yesterday, right? It's the group A/group B problem. It's the one where we have multiple stages and multiple things going on. We start off with the group A problem. call it problem number 1, group B problem, because it's accelerating. VI would be 0 meters per second there. Acceleration would be 2.0 meters per second squared. And my time interval would be 7 seconds. That's all I know for stage 1. Stage 2, down here, we're going to say that that's a constant velocity stage. So that's going to be a group A problem. And all we know in stage 2 is that the time interval is 15 seconds. And in stage 3, this is where it's slowing down, decelerating. So that's going to be a group B problem as well, where we're going to use those 5 group B equations. We know that my time interval is 8 seconds. And again, that seems like that's about all I know there. All right, let's get the displacement in each stage. Probably for this one, we're going to say VIT plus 1/2 AT squared. VIT is 0. 0 times 7, I should say. 0 times 7 is 0. 1/2 of 2 times 7 squared, 49, 98, 49 meters. But in order to solve for the displacement in stage 2, I need to know how fast it's moving in stage 2. In order to do that, I'm going to find the final velocity in stage 1. There's a couple options here. Maybe let's go A is equal to delta V over delta T. Rearrange that to get delta V. It's A times T. A is 2.0 meters per second squared. T is 7 seconds. That gives me a change in velocity of 14 meters per second. So if the initial velocity is 14 and the initial is 0 and the change is 14, then the final velocity is 14, and that makes the constant velocity in stage 2 14 meters per second. All right, so in stage 2, it's a group A problem where V is equal to delta D over delta T. We got to rearrange it to solve for D, get rid of the T by multiplying. So it looks like D is equal to V times T. We've got 14 times a time of 15. That's going to be 210. Is that right? 210? Okay, there's another displacement. Now stage 3, it's deceleration, but it starts off at what velocity? 14 meters per second. So we're going to say VI here is 14 meters per second. And then we're going to say, what are we going to say? Oh, we know what VF is, right? Missed that one. We know that VF here is 0 meters per second. So I think we're going to say D is equal to VI plus VF over 2 times T. So 14 plus 0 over 2 times 8. 7 times 8 is 56. So we add those together now. 49 plus 210 plus 56, 259, 265, 315. Actually, it shouldn't be 315. It should be, technically, it should be 3 point, not 3.1 times 10 to the 2, but you're real close. 3.2 times 10 to the 2, because we'd round that up, right? Good.